might be hard to believe, but this is what the USS Nixon originally started as. We then turned this into this magnificent boat here. Now, initially, what we did was we cut this block into 3 different strips, and we took 2 of the strips and made them half of the original length. So it was about, the main hole here was about 1 foot long in kind of a square or rectangular prism-like shape, and the other 2 were about 6 inches in length. And we took these blocks and shaved them down using sandpaper for the most part to make a more aerodynamic shape, kind of making it almost like an airfoil, at least if you look at it on the side. We then added these keels on the side, cutting holes in the bottom of our holes and wedging them in there and securing them with Gorilla Glue. Now, we learned pretty quickly that Gorilla Glue expands quite a bit, and so we had to cut off some of the Gorilla Glue, but that didn't end up being too much of a problem. We then connected the side holes into the main hole using parts of what were pieces of wood that were supposed to be masts. We connected them in such a way that one side would actually be a little bit higher than the other. The idea of this was that when one side bent into the water, the other side would be still rather level. Hopefully, this would have produced a more even or straight run with the boat. It didn't, but the idea was nice. Go. I think that's close. So what we have here is the USS Nixon, and we built it modeling it after a trimaran design, which means that there's 3 holes. The idea of this was to limit resistance in the water as much as is possible, although in our execution of our design, the holes came out to be a little bit uneven, which caused some turbulence and some trouble down the road. But the nice thing about this design is that in the water, it was very stable because of the 3 holes. Now, the center of effort with our boat was mostly going forward. Through this jib here, it pulled the boat in a kind of inadvertent straight line. The center of resistance was going backwards, but because of this, it caused a little bit of weather humming, which means that our boat wanted to turn into the wind or turn into the fans, and often bumped into the sides of the tank. This we corrected this down the road with some different modifications, and but we'll talk about that. Once again, go. I think that's close enough. Alright, so when we initially built the Nixon, we quickly found out that the boat just does not work. This was because our initial sail design was a much more traditional look, with a true-to-life triangle here, and initially the sail was too tight, which didn't allow for a difference in air pressure along the sail, which would create a forward thrust. This issue we corrected by loosening the sail, but then we found that the design of the sail in general was just not accommodating to the fans, so we decided to amend it completely, and we actually chopped off part of the mast here. So with that, we added a jib here. But we found that the top of the jib was in fact too wide, which created too much torque turning the boat into the side of the tank. So what we did was we slim fastened it down with some scissors there, and that produced some better results, but nonetheless we had to do more. So for a while we experimented with a rudder. We had multiple design concepts. At first we just kind of taped a piece of metal onto the back, and this was kind of helpful and kind of not. We still didn't have a lot of consistency. At some point we turned into this side of the tank, at some points we turned into the other side, and the real battle was just to find some sort of consistent problem, because if we could identify that, we could identify at the very least something that we could do to mend the boat to make it better. That created no consistency, so we eventually removed the rudder. It came back and forth every so often when we had an issue, just to try something new, which was basically the motto of our modifications was, if it doesn't work, try something. So we then decided that we would remove part of one of the keels. This keel length was originally the same as this keel length, but we decided to again amend this so that we could produce less torque moving inside the boat. This helped significantly, but we still found it necessary to try something else yet again. So we decided to add a second jib to the end here. This was not so much for a difference in air pressure as this one, as the air would move along. This one was more so to catch the wind as it came, to produce this kind of inadvertent forward force. It worked pretty well, but we still couldn't get the boat consistently across the tank. So we decided to add these different counterweights in. We added them in small increments of about 1 or 2 washers at first, and then decided to increase it to more drastic levels as time progressed. We tried all different positions. We have holes in multiple parts of the boats from a different point where we tried. And by some miracle, we were able to get the boat across with this final design as you see it now. The Nixon still doesn't travel very consistently. A lot of the boat is success determined by the release. So, the USS Nixon traveled across both tanks in a whopping time of 28.83 seconds, which, given the maximum time requirement of 30 seconds, was a job just good enough done. So that was actually a little bit disappointing to see that the Nixon performed rather poorly as far as speed was concerned. Although it should be worthy of note that when the Nixon went along and didn't actually get stuck on the sides, the Nixon went pretty well. Its only problem was that it did tend to weather helm rather significantly, despite our numerous modifications. So, given more time, or maybe the opportunity to simply rebuild the hull of our boat, we could have prevented some of this weather helming. But all in all, the Nixon, similar to the man, just got the job done. There were two main forces acting on our boat as it crossed the tank. The first principle, or force acting on it, was related to Bernoulli's principle. Now, this stated that because our sail formed in the shape of a relative airfoil, or at least that curved shape that there was a difference in air pressure on either side of the sail. So this was because if you look on this side of the sail, there's a greater surface area because it's bulked out like this. And this meant that in order for the air to catch up at the end, the air had to travel faster over the front part of the sail. Now, faster moving air creates a lower pressure zone. This meaning that the inside of the sail was a higher pressure zone. And objects tend to move from higher pressure zones to lower pressure zones. That's just how science works. So this created a forward thrust motion propelling our boat along the tank. Now, the second principle that was acting, or force acting on our boat, was related to Archimedes' principle. Now, this stated that the mass of the boat was equal to the amount of water, or the weight of the water that it displaced. This also meant that because our boat was less dense than the water, it was able to float. So without Archimedes' principle, our boat would have been a submarine. And without Bernoulli's principle, our boat just wouldn't have moved.